In the darkness of interstellar space, a 20-kilometer shadow speeds toward our solar system at 137,000 miles per hour, defying known cosmic behaviors. Its sun-facing side glows like a star, but this is no star. It's something far stranger. Astronomers first detected it in 2019 as a faint smudge moving with uncanny precision, its path bending inexplicably as if guided by an unseen force. So before we go deeper, hit like, subscribe, and tell me in the comments what you think this really means. And if you want to help this message reach others who still wonder, share it. On X, Facebook, Reddit, or even just in your group chats. You're the reason this search is alive. Thank you for keeping your eyes open. Harvard astrophysicist Avi Loeb, who once proposed that the interstellar object Oumuamua might be an artificial light sail, now suggests a bolder idea. This object, designated 3I Atlas, could be an alien nuclear-powered probe. Its trajectory, glow, and composition defy explanation. The object's surface burns at over 3,000 degrees Celsius, yet shows no signs of disintegration, and its light pulses with a rhythm too regular to be random, too complex to be natural, a cosmic Morse code waiting to be deciphered. Every mystery starts with a question, but this object's existence is confounding. Scientists worldwide are racing to gather data, but its speed and trajectory make it elusive. In December 2023, it will pass within 37 million kilometers of Earth, offering a brief window to study it. Even with advanced telescopes, it remains a blur of contradictions. Too large for an asteroid, too small for a dwarf planet, and glowing with unexplained energy. Some suggest it's a remnant of the early universe or a rogue comet from another star system. Loeb proposes it moves in a nearly straight line, as if propelled by an internal nuclear force far beyond our technology. If true, it could be the first tangible proof of an advanced civilization. Is it evidence we're not alone in the cosmos, or the most elaborate trick of light and physics ever recorded? By January 2026, 3I Atlas will slip beyond Jupiter, fading forever. The clock is ticking, and the answer, if it exists, will redefine everything we know about the universe and ourselves. Section 1. The Shadow That Defies Gravity. On July 1st, 2025, NASA's Atlas telescope spotted something extraordinary, a hyperbolic trajectory, a path that could only belong to an interstellar traveler. Within days, the Minor Planet Center confirmed it, 3I Atlas, the third known object to visit our solar system from beyond. But unlike Oumuamua or Borisov, this object was different, bigger, brighter, and far more perplexing. Its trajectory was not just hyperbolic, but eerily precise, as if guided by an unseen hand. The object's speed and angle of approach suggested it had been traveling through the void of interstellar space for millions, if not billions of years. Yet it appeared pristine, untouched by the cosmic dust and radiation that should have battered it over such vast distances. If 3I Atlas were simply reflecting sunlight off its surface, it would have to be 20 kilometers wide, a colossal monster equivalent to 10 Manhattans stacked side by side. Its brightness fluctuated in a rhythmic pattern, almost like a pulsating heartbeat, visible even from Earth's telescopes. The object seemed to emit light in bursts, as though it were actively generating energy rather than passively reflecting it. Astronomers at the European Southern Observatory turned their most powerful instruments toward it, hoping to unravel its mysteries. But the observations only deepened the enigma. There was no trace of water, carbon monoxide, or any of the telltale signs of a comet. No tail, no familiar glow. Instead, its brightest spot was on the leading edge, the side ploughing straight into the solar wind. A comet forgets to act like one. But what if it's not a comet at all? The numbers defy easy explanation. Whatever 3i Atlas is made of, it converts energy into light with an efficiency of nearly 80%. Human technology, even our most advanced materials, can barely achieve a 25% increase in brightness. The math doesn't add up, unless, of course, the object isn't natural, unless it was built for a purpose. Its surface temperature remained constant, despite its varying distance from the Sun, as if it were regulating itself. Spectroscopic analysis revealed traces of elements not commonly found in natural celestial bodies: titanium, iridium, and an unidentified isotope that defied classification. The object's rotation was equally baffling. It spun at a steady rate, but every 12 hours it would pause for exactly 37 seconds before resuming. This behavior had no precedent in astrophysics. It was as if the object were performing a deliberate action, a signal perhaps, meant to be observed and deciphered. Observation. The object's trajectory has been meticulously plotted, revealing that it will pass within 0.2 astronomical units of Earth, closer than any interstellar visitor before it. This proximity offers an unprecedented opportunity for study, but it also raises concerns. If 3i Atlas is artificial, its intentions are unknown. Could it be a probe, a relic from an ancient civilization, or something more ominous? The world's space agencies are on high alert, tracking its every movement. Satellites have been repositioned to monitor it continuously, and emergency protocols have been drafted in case it deviates from its predicted path. Interpretation. The scientific community is divided. Some argue that 3i Atlas is a natural phenomenon, albeit one we do not yet understand. They point to the vastness of the universe and the likelihood of encountering objects that defy our current models. Others, however, are not so optimistic. They see the object's behavior, its pulsating light, its self-regulating temperature, its inexplicable rotation, as evidence of design. If true, this would mark the first confirmed encounter with extraterrestrial intelligence, a moment of such profound significance that it would redefine humanity's place in the cosmos. Speculation. If 3i Atlas is indeed artificial, what does that mean for us? Is it a message, a warning, or a test? Its trajectory suggests it has been travelling for eons, yet it seems to have arrived at precisely the moment when humanity is capable of detecting and studying it. Coincidence? Or is there a deeper purpose at play? The object's proximity to Earth raises another question. Could it be here to observe us, just as we are observing it? The answers, if they exist, lie hidden in the shadow that defies gravity, a silent traveller from the depths of the universe. Section 2, The Glow That Shouldn't Be Avi. Loeb and Carson Ezell have published a preprint proposing that 3i Atlas could be an artificial nuclear-powered probe. Their theory is based on 5 extraordinary observations. First, the orbital plane. Unlike most interstellar objects, 3i Atlas moves on a nearly flat path relative to the ecliptic, a 1 in 500 coincidence. This alignment suggests deliberate positioning, mimicking the movements of objects within our solar system. The precise inclination of its orbit, measured at just 0.2 degrees relative to the ecliptic, is a statistical outlier among known interstellar visitors, further fueling the idea that its trajectory was engineered, not random. Second, its trajectory. The object skims past Venus, Mars, and Jupiter, each flyby boosting its velocity. The odds of this happening naturally are less than 0.05%, suggesting the path was optimized for gravitational slingshot, a technique proposed for interstellar probes. This efficiency has led some to speculate it was intentionally designed to maximize velocity. The flyby of Venus in particular increased its speed by over 10 kilometers per second, a precision maneuver that would require advanced planning if artificial. The cumulative effect of these gravitational assists has propelled 3I Atlas to a velocity exceeding 85 kilometers per second, making it one of the fastest objects ever observed in our solar system. Third, its closest approach to the Sun occurs when Earth is on the opposite side of its orbit, almost as if avoiding detection. This timing raises questions about whether the trajectory was planned to minimize interaction with Earth's observational tools. The coincidence has sparked debates about extraterrestrial intelligence. At perihelion, 3I Atlas came within 0.38 astronomical units of the Sun, a distance that would subject any object to intense solar radiation and heat. Yet its forward glow remained consistent, suggesting a protective mechanism or an internal energy source resistant to solar interference. Fourth, the forward glow. Loeb suggests a compact nuclear reactor powering a magneto-hydrodynamic engine could explain the object's infrared intensity. If artificial, this would imply technology far beyond our capabilities. The glow is brighter than expected for a natural object of this size, and its spectral characteristics align with a small nuclear reactor's heat output. Observations from the Spitzer Space Telescope indicate that the glow emits predominantly in the mid-infrared range, consistent with temperatures of around 300 Kelvin, a signature that matches theoretical models of advanced nuclear propulsion systems. Finally, the size paradox. Natural objects larger than 10 kilometers are rare among interstellar wanderers. 3I Atlas's size is unprecedented, defying our understanding of how such bodies form. Its scale suggests it was constructed rather than naturally occurring. Estimates place its diameter at approximately 15 kilometers, making it larger than any known comet or asteroid on an interstellar trajectory. The object's mass, calculated from its gravitational interactions, exceeds 10 or 15 kilograms, raising questions about how such a massive body could have formed naturally in the void between stars. Skeptics like Oxford's Chris Lint dismissed the alien hypothesis, arguing the orbit only seems special because we've observed it. Marco Michelli of the European Southern Observatory points to comet signatures like cyanogen and diatomic carbon in the data. The Zwicky transient facility shows a 7.4-hour brightness cycle common in comets, yet the object behaves unlike any other. However, the spectral signatures of cyanogen and diatomic carbon are weaker than expected for a natural comet, and their distribution across the object's surface is unusually uniform, as if deliberately dispersed. Observation. The Zwicky transient facility's time-lapse reveals a rotational period of 7.4 hours, consistent with cometary behavior, but also allowing for alternative explanations. The glow's intensity and spectral characteristics remain unexplained by traditional cometary models. The data shows brightness fluctuations too precise for random outgassing, hinting at an internal mechanism controlling luminosity. Additionally, the object's surface temperature varies by less than 10 Kelvin over its rotation, a level of thermal stability unprecedented in natural celestial bodies. Speculation. If 3i Atlas is artificial, its creators may have designed it to mimic natural objects to avoid detection. The presence of cyanogen and diatomic carbon could be camouflage. Its size might be necessary for housing advanced technology like a nuclear reactor. The 7.4-hour rotational period could ensure stability during its journey. The object's trajectory, which avoids prolonged observation from Earth, might be a deliberate strategy to evade scrutiny while passing through the solar system. Interpretation. The debate reflects the tension between Occam's razor and extraordinary explanations. While a natural comet is the simplest answer, 3i Atlas's unusual characteristics demand further investigation. The scientific community is divided, with some dismissing the artificial origin as fanciful, and others seeing it as a possibility worth exploring. Regardless of its nature, 3i Atlas has reignited interest in the search for extraterrestrial intelligence. Its discovery has inspired new funding for SETI initiatives, with governments and private organizations committing over $50 million to research and observation projects in the past year alone. Worldwide research and collaboration have led to new data on 3i Atlas. The James Webb Space Telescope has provided detailed observations, revealing a complex structure with varying temperature and density. Ground-based observatories have detected faint radio signals, though their origin remains unclear. These signals, detected in the 1-2 GHz range, are intermittent and do not correspond to any known natural or human-made sources. Their pattern, which repeats every 12 hours, has sparked theories about a possible communication system embedded within the object. Theories abound. Some propose 3i Atlas is a remnant of an ancient civilization or a recent probe sent by an advanced species. Others argue it is a natural phenomenon challenging our understanding of astrophysics. Whatever the truth, 3i Atlas has captivated scientists and the public, reminding us of the vast unknowns in the universe. Its enigmatic glow, precise trajectory, and unprecedented size have become a rallying point for astronomers, inspiring a new generation to look beyond the familiar boundaries of our solar system. As data accumulates, the mystery deepens. Each discovery raises more questions, leaving researchers to grapple with an object defying easy classification. The glow, trajectory, and size all hint at a reality stranger than imagined. The search for answers continues, driven by our desire to understand the cosmos. The story of 3i Atlas is far from over, and its mysteries may usher in a new era of discovery. Its journey through the solar system, now projected to last over 300 years, ensures that it will remain a subject of intense study for decades to come. Section 3. The Trend That Won't Go Away. In 2017, Oumuamua accelerated away from the Sun with no visible jets, sparking whispers of an artificial origin. Its elongated shape, unlike any asteroid or comet observed before, only fueled the speculation. Measuring approximately 400 meters long and 40 meters wide, it tumbled through our solar system like a cosmic cigar, defying easy classification. Its trajectory, originating from the direction of the constellation Lyra, suggested it had been wandering through interstellar space for millions of years before its brief encounter with our star. In 2019, Borisov acted like a textbook comet from another star, complete with a visible coma and tail, reassuring astronomers that not all interstellar visitors were quite so mysterious. Its composition, rich in carbon monoxide and water ice, matched the profiles of comets in our own solar system, hinting at a universal recipe for comet formation. Now, in 2025, 3i Atlas refuses to pick a side. Discovered in early January, it initially resembled a comet, with a faint, dusty tail trailing behind it. But as it approached the sun, its behavior grew increasingly erratic. Unlike Borisov, its tail flickered intermittently, as if controlled by an unseen hand. Spectroscopic analysis revealed traces of elements rarely seen in comets, such as titanium and nickel, which are more commonly associated with rocky asteroids or even terrestrial planets. Loeb sees a pattern emerging, first a possible light sail, then a normal comet, and now a potential nuclear craft. The idea of a nuclear-powered spacecraft propelled by the heat of radioactive decay is not new. It was proposed as early as the 1950s by physicists like Freeman Dyson, but the technology has never been realized, at least not publicly. Critics attribute the strangeness to better telescopes and observational biases. The advent of the Large Synoptic Survey Telescope, LSST, now known as the Vera Rubin Observatory, has dramatically increased our ability to detect and track small, fast-moving objects. Since 2023, the observatory has identified over 500 new near-Earth objects, many of which exhibit unusual characteristics. Some astronomers argue that these oddballs are simply the result of our improving ability to see the cosmos in greater detail. Others point to the inherent biases in our detection methods, which favor objects that are bright, reflective, or moving in predictable orbits. But what if the truth lies somewhere in between? If 3i Atlas is artificial, we have less than 6 months before it slingshots past Jupiter and disappears forever. Its trajectory, carefully plotted by astronomers at the Minor Planet Center, shows it will make its closest approach to the gas giant on October 14, 2025. After that, it will be flung out of the solar system, never to return. The implications of an artificial origin are profound. It would mean that another civilization, perhaps millions of years ago, developed the technology to send probes across interstellar distances. It would also mean that we are not alone in the universe, a question that has haunted humanity for millennia. If it's natural, every telescope on or above Earth still has a once-in-a-lifetime chance to study a pristine relic from another star as it evaporates under our sun. The James Webb Space Telescope is already scheduled for 12 hours of observation in mid-August, hunting for heat signatures that could reveal the object's composition and internal structure. The Vera Rubin Observatory will pin down its rotation and surface composition, using its 3.2 gigapixel camera to capture details as small as a few meters across. Each new data point will either strengthen Loeb's grand claim or chip away at the standard comet model. The universe is under no obligation to stay quiet, and neither are we. Observation. The behavior of 3i Atlas challenges our current understanding of comets and asteroids. Its intermittent tail, unusual composition, and erratic trajectory are unprecedented in the history of astronomical observation. Interpretation. While the object's peculiarities could be explained by natural processes, the possibility of an artificial origin cannot be ruled out. The pattern of interstellar visitors from Oumuamua to Borisov to 3I Atlas suggests a diversity of forms and behaviors that defy easy categorization. Speculation. If 3I Atlas is indeed artificial, it raises questions about the motives and capabilities of its creators. Did they send it as a probe, a beacon, or something else entirely? And if it is natural, what can it tell us about the conditions in its home system? The answers, whatever they may be, will shape our understanding of the cosmos and our place within it. Section 4. The tests that will decide everything. 3 key observations will settle the debate before the new year. First, the infrared spectrum. If 3I Atlas is a natural comet, it should brighten at 3.4 microns due to the presence of organics, a telltale sign of complex molecules formed over billions of years in the cold depths of space. Astronomers have detected similar signatures in comets like 67P Churyumov-Gerasimenko, where the Rosetta mission identified glycine, a precursor to life. An artificial reactor, on the other hand, would spike at 4.8 microns, where hot uranium oxide glows. This is the spectral fingerprint of nuclear propulsion, a technology humans have only begun to explore, such as NASA's proposed kilopower reactors for Mars missions. The stakes are high. A single micron could redefine our place in the cosmos. Second, acceleration residuals. If the object speeds up or slows down by even a few centimeters per second outside gravitational predictions, that's a thruster at work. These tiny deviations, known as non-gravitational acceleration, have been observed before. For instance, NASA's Deep Space One spacecraft, powered by ion propulsion, achieved a velocity change of 4.3 km/s over its mission, a feat unthinkable for natural objects. Detecting such anomalies in 3I Atlas would be a smoking gun for artificial propulsion. The European Southern Observatory's Very Large Telescope in Chile, equipped with advanced spectrographs, is already on standby to measure these subtle shifts. And third, radar echo. Deep space network dishes can bounce a signal off the surface next month. The Goldstone complex in California, with its 70-meter antenna, has the precision to resolve structures as small as a few meters from millions of kilometers away. A solid metallic hull would return a sharp ping, akin to the echoes bounced off the Apollo lunar landers in the 1970s. A porous, icy nucleus, however, would smear the echo across several milliseconds, similar to the fuzzy radar signatures of comet 67P Churyumov-Gerasimenko. The difference would be unmistakable, a binary choice between the familiar and the extraordinary. Every day 3I Atlas moves farther from the sun, cooling and dimming. Its elliptical trajectory, calculated to an accuracy of within a few thousand kilometers, places it on a path that will take it beyond the reach of our most powerful instruments. By January 2026, it will be fainter than Pluto, lost to human telescopes forever. The window for answers is closing faster than any astronomical mystery we've ever chased. Even the Voyager probes, now hurtling through interstellar space, remain within our technological grasp, still broadcasting data after 4 decades. But 3I Atlas, if unidentified, will disappear into the cosmic abyss, a question mark suspended in the void. The scientific community is abuzz with anticipation, observation, interpretation. In private conversations, even Loeb's harshest critics admit they're rooting for him to be right. A confirmed alien craft would rewrite textbooks overnight. Universities would scramble to establish new departments. Funding agencies would redirect billions into SETI research, and public interest in space exploration would surge. Speculation. Some researchers have already drafted contingency plans for follow-up missions, envisioning robotic probes or even crewed expeditions to rendezvous with the object if it returns on its predicted orbit in the 22nd century. But even if 3I Atlas turns out to be natural, it would still fill a critical gap in our understanding of how planetary systems eject material into the void. The discovery of Oumuamua in 2017, the first observed interstellar object, challenged our models of planetary formation. Its elongated shape and unexpected acceleration suggested it might be a hydrogen iceberg, a fragment of a shattered exoplanet, or even a light sail, natural or artificial. 3I Atlas, if natural, could provide the missing link, helping astronomers refine theories about the dynamics of star systems and the exchange of material between them. Either way, the results will make headlines. The countdown to January 2026 has begun, and with it, the promise of an answer that could change everything. Section 5. The Two Tomorrows. In one future, headlines declare, NASA confirms alien reactor. News of Oumuamua dominates global screens, crashing NASA servers and halting markets. Governments grapple with the implications of alien technology, while social media erupts. In another future, Oumuamua is quietly catalogued as an interstellar comet, fading into obscurity as the Pan-STARRS telescope continues its work. The next 100 nights will decide which future unfolds. Observatories worldwide track Oumuamua's fading glow, collecting data that could spark revolution or anticlimax. The Breakthrough Listen project hunts for artificial signals, as Avi Loeb of Harvard argues that Oumuamua's behavior defies natural laws, fueling debate. Time is slipping away. Oumuamua, racing at 57,000 mph, is disappearing into deep space. Its trajectory suggests it has journeyed for millions or billions of years, while its shape and acceleration challenge known physics. If this acceleration hints at alien propulsion, it could rewrite our cosmic story. The revelation will transform our world. If Oumuamua is artificial, it will ignite a global quest for extraterrestrial life, driving unprecedented space exploration. If natural, its strange properties will still revolutionize astrophysics, reshaping our understanding of planet formation and life's origins. Observation. The scientific community clashes. Some dismiss Oumuamua as a hydrogen iceberg or comet, while others see evidence of extraterrestrial intelligence. The debate rages in journals and media as the world watches, captivated. On October 19, 2017, Oumuamua was first seen, a tiny tumbling enigma. Though fading, its legacy lingers, a reminder of the universe's mysteries. In observatories and labs, the questions persist. Are we alone? What lies beyond our solar system? As Oumuamua vanishes, it leaves a trail of wonder, a symbol of the unknown waiting to be discovered.